everybody is sick. Everything, everyone, everybody is sick.
Today, we're introducing an innovative approach to training large-scale AI models with Flock. Flock users can be a training node by using everyday devices like laptops, PC, and even tablets. This lets users build their own personalized large language models and earn token rewards, all while ensuring their data is completely private at every stage. We're providing a platform called FL Alliance that enables users from different regions around the world to collaborate in training and improving model performance and AI creation together. Notably, this is for large language model training, not just inferencing. It is the new age of decentralized AI, led by Flock. Next, we will use 3 devices as a cluster to explain how Flock's FL Alliance works. Let's assume we're fine-tuning a large language model using 3 Macs. First, we'll set up a MacBook Air with an M2 chip and 8 GB of memory as the master node, which will normally be users' own consumer-grade machine. It doesn't need to be very powerful, but should have access to the training data to coordinate the process. Next, we'll configure 2 more powerful but still accessible devices: Mac Minis with 16 GB of memory and an M4 Pro chip as worker nodes, which will only provide compute resources. All 3 devices are connected via the gRPC protocol. Shout out to open source contributors like Exolabs for their communication layer wrapper over gRPC. In this stage, we will specify a large language model, such as Llama, that you want to fine-tune using your own data. The large language model will be sharded across devices based on the proportion of their memory sizes within the entire distributed environment. The model will primarily be divided into 3 components: the model head, model mid, and model tail. The model head and tail will be hosted on the master node, while all worker nodes will host the model mid. Apart from model preparation of all devices, the master node especially needs to prepare the training data, along with the corresponding labels. And then we can begin the formal federated decoupled training process. Firstly, the Flock Alliance client will be launched on the master node to stake Flock tokens and specify the fine-tuning task you want to participate in. Then, the federated learning proposer step will be initiated. Model will be updated while all user data keeps local on user's own node. Only the model updates are transmitted to the worker nodes, aka other network participants in the training. After that, the voter step will start. Model updates will be aggregated into a new global model. The new global model weights will then be used to update the shards of large language model hosted on each device, with the corresponding parts being updated on the respective devices. And next, each voter uses their own data to evaluate the updated large language model weights, following the same forward-pass process as the proposer. Eventually, the loss value will be converted into a voting score: -1 for performance decrease, 0 for no change, and 1 for improvement. Accordingly, the voting score will be submitted to the Flock network, and voters will receive Flock coins as a reward for their contribution. At the same time, proposers will either receive Flock coins as a reward or have coins slashed as a penalty based on the evaluation result of their contribution. Flock.io is a decentralized AI model training and validation network, empowers multiple collaborators to train large language models effectively. We now support Apple Silicon devices. We'll soon onboard more personal computer and mobile device. While centralized AI companies trying to steal your personal data for their own model training, Flock's FL Alliance is the only way for private data to be fully and securely utilized. Join the FL Alliance private beta today at alliance.flock.io. Join the Flock, join the revolution.